Video covers section 5.1, quadratic functions. So we're going to start working on characteristics of parabolas, how those graphs look. We're going to find minimums and maximums, and we're going to do some application problems using a quadratics maximum and minimum value. Let's go ahead and start with our warm-up here. And at any point, pause the video to process the information before moving forward. Since this is recorded, you can pause, right? So for the warm-up, we want to factor. I know that this is a difference of squares. So I know that this is going to be my perfect square. So that's a difference of positive 5 and negative 5. And so for factoring, that's all I have to do. If I'm interested in solving, on the other hand, I'm going to look for two numbers. One of them needs to multiply. One thing it needs to do is multiply to negative 15. It also needs to add up to negative 2. So I am trying to think of numbers that would do that, and I'm thinking negative 5 plus 3. So I have x squared minus, let's do plus 3x minus 5x minus 15. We can factor out an x, factor out a negative 5, and we'll end up with this guy equal to 0, which means x is 5 and x is negative 3. Okay, so we have two solutions there. If we have something with a coefficient that is not a 1, we'll do the same thing, but now we're interested in multiplying to 3 times 15, which is negative 45, and adding up to negative 4. So now that's going to require thinking a little bit about my factors of 45. I'm going to end up choosing negative 9 plus 5. That's going to work. So let me go ahead and rewrite 3x squared minus 9x plus 5x minus 15. We'll factor out a 3x, factor out a 5, and now I have 3x plus 5 and x minus 3, and x is going to equal negative 5/3 and 3. I have two answers, both factored. Okay, let me continue here. I'm going to move this text over slightly so that I have room to write the next portion. I'll draw a little arrow. Okay, so let's talk about the axis of symmetry on a parabola. A parabola is just the graph version of a quadratic. And the axis of symmetry is the halfway point of the curve. And if you were to fold it like a sandwich, it would fold over this line. I don't really know how a good way to write that. So I'm just going to say it again. If you wanted to fold the parabola, it would fold over this line evenly. So you'll notice it's right here, right down the middle. Okay. You'll also notice that it touches the vertex. The vertex is also at the center of the curve. Okay. It is the lowest or highest point of the parabola, depending on if it's positive or negative. Okay. The x value is the same as the axis of symmetry. Okay. Now, in order to find the coordinates of the vertex, you might not have it in front of you. There is an equation. Your textbook, if you've been following along in it, uses h instead of x sub v. I like to use x sub v because it reminds me that I'm looking for the x coordinate of the vertex. And the equation is negative b over 2a. So that comes from your standard form of ax squared plus bx plus c. okay? Let's do an example of that here on the next page. So in this example, I'm interested in finding the vertex, intercepts, and then I'm going to draw a sketch. So for the vertex, I have the x-coordinate is -4 over 2a, which is -4 over 2, or -2. So that is the x-coordinate. The y-coordinate, which I glossed over, is when you plug in that value into the equation, you get the y-coordinate. So if I plug in -2 squared plus 4 times -2 plus 3, that is going to get me my y-coordinate. So we have 4 minus 8 plus 3, which gets me -1. So my vertex is going to be -2, -1. That is the first piece of information I need. Then we'll find the x-intercepts. I'll do that in blue. I want to multiply to 3 and add to 4. So that tells me I'm going to use 3 and 1. So my first x-intercept is -3, and my second one will be -1. That was a quick one. My y-intercept is going to be a 3, right? It's the number without any variables. So now I have quite a bit of information in order to sketch. So I don't have any I don't have any tick marks on here, which is fine. I'm gonna ballpark it. So that'll be -1, that'll be -3. This will be +3. Let me switch back to purple here. And then we'll treat this as -2, -1. And so now if I draw my curve, here we go. That'll be a quadratic with all the information I found. Let's do the same thing for this next one. I'd like for you ideally to try it. If you're still unsure, you're welcome to just continue watching. Let's go ahead and find the vertex. We have -6 over 2a. So that's going to be -6 over 6, or -1. So let's plug that in for yv. 3 times -1 squared plus 6 times -1 minus 5. So that's going to be 3 minus 6 minus 5, which will be -8. So our vertex is -1, -8. Okay. For our x-intercepts, we are going to multiply to -15 and add up to 6. I'm trying to think of numbers that can do that, and I'm not coming up with anything, so we might need to use the quadratic formula. Okay. Let me think here briefly. 1 times 15 won't work, and 3 times 5 won't work. Yep, so this might be a quadratic formula situation. Okay. So that's going to be -6 plus or minus 6 squared minus 4 times a times c all over 2 times a. I'm going to do that math on my end here. So we're going to have -6 plus or minus, looks like 36 plus 12 times 5 is 60 all over 6, which is going to be -6 plus or minus root 96 all over 6. Now, we are going to end up getting decimals. It looks like 96 is not a perfect square. So on your end, go ahead and solve that while I solve it over here. Give me just a moment. I'm doing this in live time. We are going to end up with -2.6 and 0.6. Okay, those are going to be our two answers. Okay. Then we have the y-intercept, which is -5. So let's go ahead and stick that in here. Whoops. 0, -5. And now we have enough to graph. So here's my y-intercept. Here are my x-intercepts. So we'll say 0.6 and -2.6. We'll say -5. And then we're going to be at -1, -8. Okay, rough sketch, nothing super crazy. And then I will draw my curve. Okay. Now, what if you want to write an equation from the graph? That's going to mean starting with your vertex, right? We talked about there being a form of the equation using vertex form, and it looks like this. Y equals a, x minus h squared plus k, where hk is your vertex. So this is a good starting point. A is your stretch factor. So let's go ahead and plug in what we know. We know our vertex is -2, -3. So let's go ahead and plug that in. X minus -2 will be +2, and then -3. Now I need to find A. So I'm going to choose my y-intercept to plug in. -1 equals A, 0 plus 2 squared minus 3. I need to go ahead and solve for A. Okay, I'm going to add 3 and I'll have 2 equals 4A, or A equals 1/2. So that means my function is 1/2 parentheses x plus 2 squared minus 3. That is the equation of the function. Next up, we have an application problem. Okay, a backyard farmer wants to enclose a rectangular space for a new garden in her fenced backyard. She purchased 80 feet of wire fencing to enclose 3 sides. She's going to use a section of the backyard fence as the 4th side. So there's not going to be a fence here. There is going to be a fence here, here, and here. Okay, let's keep reading. Find a formula for the area enclosed by the fence if the sides of fencing perpendicular to the existing fence have length L. What dimension should she make her garden to maximize the enclosed area? Maximizing really talks about the vertex. Okay, that means our vertex is going to be at a maximum point, like this. That's a maximum. So first, let's start by writing out the perimeter for this scenario. Okay, we know that the perimeter is 2 length plus 2 width, usually. In this scenario, one of those widths we're not using. So our perimeter is 80 feet of fencing is 2 lengths plus 1 W. Okay. We also know that area is length times width. I'm going to move that over here to the side because that'll become relevant in a minute. Let's go ahead and set this one equal to W. We'll say 80 minus 2L. And now we can rewrite length times width as length times 80 minus 2L. This, guys, is a quadratic. 80L minus 2L squared. Right? If we're interested in finding the maximum, what we want to do is find the vertex. So I'm going to rewrite this in order from highest to lowest. And now I'm going to find the x-coordinate of the vertex. -80 over 2a is -80 over -4. Okay, and that's going to be 20. So we have a length of 20, okay? And that is going to be our x-coordinate. So this is xv. If we're interested in finding yv, that's going to be our maximized area. Okay, notice that when you plug it in, you get 800. So let's plug in, let's see, 20, 80 times 20 minus 2 times 20 squared is going to be 800. Okay, and that's going to be your area. So to maximize your area, you want to use a length of 20. I forgot the units. Feet. 20 feet. Units are important. Okay. Let's take a look at another application problem. Something that you see all the time with quadratics is projectile motion. Apologies. Lost my words there for a moment. Okay. Projectile motion is really, really common. Projectile motion is like a ball being thrown in the air or jumping up and then coming back down. So no matter what you throw up, it's going to come down because gravity exists. So in this scenario, a ball is thrown upward from the top of a 96-foot building at a speed of 80 feet per second. The ball's height above ground can be modeled by this equation, which is given. When does it reach maximum height? What is the maximum height? And when does the ball hit the ground? These things are asking three different things. When it reaches maximum height is the x-coordinate of the vertex. The maximum height is the y-coordinate of the vertex. And when it hits the ground is the x-intercepts. Think about it. If we are starting at 96 feet, we're going to hit a maximum somewhere, and then we eventually have to touch the ground again. We just don't know where. So let's start by finding the x-coordinate of the vertex. We have negative 80 over 2 times negative 16. That's going to be negative 80 over negative 32. Yes, it's fine that this is going to be a decimal because we're working with time and we're not really expecting this to be a perfect number. So right now we have discovered that the time it takes to reach the maximum is going to be 2.5 seconds. So 2.5. So this is 2.5 seconds. Now we need to find the y-coordinate. So we have negative 16 times 2.5 squared plus 80 times 2.5 plus 96. So let's go ahead and plug that in. I'm going to open my calculator because I don't have one otherwise to show you. So negative 16 times 2.5 squared plus 80 times 2.5 plus 96. So we reach an overall height of 196 feet. Close that. We don't need it anymore. So our maximum height is 196. So right around here. Okay. 196. Finally, we need to find our x-intercepts. That requires using the quadratic formula. So negative 16 t squared plus 80t plus 96 equals 0. Let's plug this into the quadratic formula and solve. At this point, we've used quadratic formula quite a bit. You are going to end up with two answers. One of those answers is going to be negative. You are not going to use the negative answer. Okay? It doesn't make sense to use a negative number as your answer because time isn't negative. So it's not going to be a valid answer to the problem. Okay? The correct answer is going to be 6. The negative number is -1, if you're curious. Okay, so 6 seconds is when it hits the ground. So that allows us to draw this curve showing the motion of the ball. Okay. The last question is similar. This should be negative 16t squared, not t2. And again, Jason is cliff jumping in Acapulco. He's having a good time. Time is in seconds, h is in feet. How long does it take for him to reach his maximum height? What is the highest point that he reaches? And when does he hit the water? Same exact scenario. So let's go ahead and find the x-coordinate of the vertex. Then we'll find the y-coordinate of the vertex. And then we'll find the x-intercept. Okay? So we have negative 16 over 2 times negative 16, which is going to be 16 over 32, or 0.5 seconds. So it's very quick, okay? He does not go much higher than where he's starting. The y-coordinate of the vertex is going to be negative 16 times 0.5 squared plus 16 times 0.5 plus 480. And I again will split my view so that we can calculate that. Negative 16.5 squared plus 16 times 0.5 plus 480. It looks like 484 feet is his maximum height, so just 4 feet higher than the cliff. Okay. And then when does he hit the water? We have x-intercepts that we need to find. So negative 16t squared plus 16t plus 480 equals 0. Again, quadratic formula is your friend here. You will get 2 answers. You want the positive answer. So let's see what that comes out to. It will be 6 seconds and negative 5. So remember, that's the one we don't want. It doesn't make sense. Okay. Now, if I were to graph this, which I did not give you a graph, but we can draw a sketch. We started at 480. Okay. And then we touched down at 6 seconds. Whoops. And at 0.5 seconds, we had our maximum of 484. So here is, let me adjust my point here slightly so it looks a little bit better. There we go. Okay, so there is my curve. All right. That covers it for quadratics.